Okay, I'm gonna try and be as quick as I can showing the most vital information. Okay, so I ran a couple of these before just so I can show them easier. So we have Suricata running, we have Kibana running, Elasticsearch, Auditbeat, and as well as Filebeat, which are all of the services that we currently have running on our Ubuntu machine. So let's take a look at the Kibana YAML file. So we have it configured to our IP address, which we're using a bridged adapter so that we can get the Kali Linux to communicate with the Ubuntu machine when we're running our test attacks. And Kibana sits at port 5601. So when we access it on the web, that is the port, or this is the address that we will be using to access. Well, that's Elasticsearch. Elasticsearch is on 9200. To get to Kibana, we will go to HTTP 192.168.1.126 port 5601 for Kibana. Here are our credentials. And we are using HTTP. I was trying to set up SSL certification so that we could use HTTPS and log in to Kibana, but we're running into a lot of issues with the SSL tokens. And so I figured for the purpose of the project, we'll just keep it at HTTP. And with some more time, I could probably fix that issue and get it running on HTTPS so that it's more secure. Okay. Let's take a look at our let's take a look at our Elasticsearch YAML. Okay. So we have our data and our path to our logs are right here. Our IP address, the port that Elasticsearch sits on. And okay, this is where we're having some trouble with setting up the SSL. We got like half of it set up. But whenever I enable XPack security to true, this one right here, then we can no longer access the Kibana server, and we're just having many issues with setting up the SSL certification. Okay, so let's see. Let's go to our Suricata. YAML file. Okay, so we have our home net, which we set to 192.168.1.0/24, because we can see when we run the IP address command, we're using the ENP0S3, and our address is right here. So our network is going to be 192.168.1.0/24. Okay. Okay, so we have our outputs configured. The fast log and the Eve JSON are the main outputs. The Eve JSON, I had a couple of these that I was playing around with specifications. However, I noticed when I was, say, enabling like the SSH one, it was limiting what we could see in the Eve.json file. So I just left it at the default alert, so it will just take every alert and log that instead. Okay. And this is about everything that we need to see for the Suricata YAML file. Okay, just exit out of that. Let's take a look at some of our rules. So for Suricata, here are some of the rules. I have a bunch commented out just because I was trying different combinations. Like we can see for our DOS rule, I was just playing around with the count for how many packets within 1 second for it to flag as a DOS attack. And we are using for the DOS alert and the DOS attack, we'll be using a TCP SYN flood because with our Suricata, we are already blocking a lot of ICMP traffic. And so if we were to run this rule, for example, it will just be completely blocked, the ICMP traffic, and we won't get flagged because the DOS attack won't even go through. My port scan rule. We also have some more SYN scans, and these we have for like a stealth scan. But our default rule for port scan is picking up any SYN scan or stealth scan that we run. So I just decided to leave the one rule because if it's capturing all of the different types of port scans, then why add more? And let's see. Let's try. Okay. Let's run. Okay, so I'm already tailing just from tests before, already tailing the Suricata fast log. And we can see this Suricata stream three-way handshake. That was just from when I last restarted Suricata to kind of give a break between the other flags that we were getting. So let's start by just running an Nmap scan on the Kali Linux machine. And we can see that picks that up as a port scan. We get one flag. Okay. Let's now go to our stealth scan. So nmap-ss. We can see we get another port scan. And here. Let's run our DOS attack now, which we'll be using hping with SYN flood to port 80. So we're going to be flooding port 80 with a bunch of SYN packets. And just because of the way that the rules are configured, I've been trying to get it when we do run the DOS attack, it will also flag as a port scan. I've been trying to play with the count for the port scan and the count for the DOS rule, just to try and see if we can get it to only flag the DOS attack. But since they are very similar in nature, especially the rule, like this one is flagging if there are 50 packets within 1 second, whereas the DOS rule needs 1500 within 1 second. So when we run a port scan, we won't get a DOS flag, which is good. But when we run our DOS attack, we'll get our DOS flag, and we'll also get port scans because it is sending a bunch of packets to port 80, and so our rule is just going to pick that up regardless. And this will just run in flood mode, so I'm just going to kill that, and we can see that we have 100% packet loss, which is good. That even though our port is open and listening, that we are blocking the traffic. Okay, and now let's see. I think the last attack I will show is going to be the Metasploit rule. So that is this rule right here. So we'll save that. And let's restart Suricata. You see the last thing we're tailing is our potential DOS attack. So let's open up the Metasploit console, or the Metasploit framework console. So that will just take a second to start up. And there we get our flag for the ICMP request being blocked as well. Okay, so now in the MS, or the Metasploit console, let's search for our vulnerability. So we're going to search for MS08_067. So now that we see it, we're going to use exploit. Okay. We will use that exploit. And there, even before we set the exploit, it is picking up our that we're about to attack. So let's set our right host to 192.168.1.126. We'll set that, and then we will exploit. And we can see that our host refused the connection. So that's good. That the exploit wasn't successful, but we still get our flag for the exploit attempt. Okay, and I'm kind of running out of time, so I think that is all of the attacks that we're going to run. I could run the brute force attack, but that's going to take too much time. I think I only have a few more minutes. So let's take a look. Our Elasticsearch, I have just a couple things pulled up that we can look at. We can see we're on 192.168.1.126, port 5601, and these are our dev tools. So in our console, our dev console, we ran this to make sure that we're getting everything, all the logs from our Filebeat, and we can see in this window, we have hundreds of lines of information from Filebeat. Let's see, we also can go to our log stream And we can see from the Suricata Eve, or the Eve JSON file, our messages that are updating in real time. Let me scroll over to this big spike where we had a bunch of requests. So we can see some of our information for this. All right. And let's go to our overview. So we can see right here, let me just refresh the page just in case. So we are getting log events. Okay. Okay, and so this is only showing for the last like 15 minutes. And so we can see we got a bunch of stuff from the Suricata Eve file, or the eve.json file, from when we were running those attacks. Let's see, I'll just change it to the last 7 days. We can see some big spikes from just some other attacks that I was running. All right, and now let me refresh. This is our Filebeat Suricata overview. I'm sorry that it's a little slow. It's just running two of these virtual machines, I think, is slowing down my computer a little bit. Okay, so as this is loading, we can see the most common alert signatures. And we can scroll down. Okay. And now when we go down here, we can see where we were running. This is when we were targeting port 80. And then after some of the, and then these are from our Metasploit exploit. We can see all of these. There's going to be thousands of these for going to port 80, or for the destination port is port 80, because when we were doing our DOS attack, it is just sending an endless stream of packets to be handled. Okay. Let's see. And let's just tail the eve.json file. This one, it's not as readable. Which I tried running JQ to kind of visualize the Eve JSON in a more readable format. I'm just not sure. I could not get JQ to work in a way that would display the Eve JSON logs in a readable manner. I think with some more time, I can, after this course is over, I'll continue to work on this just for my own sake, but I think I could refine this a little further. But overall, I've definitely enjoyed this project. It was difficult, but very rewarding when we start to get things working, and seeing rules that we implement work, and running attacks and seeing the flags pop up, and then being able to see those pop up in our dashboard is really interesting. And I think I want to continue to work on stuff like this in my own time, even after the course is over. Um, so I think that's everything for my that I have to show. If there's any additional things that need to be shown, I'm happy to submit them or show them. But I'm not really sure what else there is to show. So that is my network IDS integrated with the SIEM Lab, and we ran a few attacks. All right, I think that's it.